In the world of aviation, there are rules. One of those rules is that you never, ever put an engine on top of a wing. It creates drag, it ruins lift, and it's an aerodynamic nightmare. But Honda, a company known for Civics and lawnmowers, decided to ignore 70 years of aerospace physics. They spent 30 years in secret hangars, used the high-end Italian stiletto shoe as their blueprints, and created a flying supercar that literally defies the wind. This is the HA420 HondaJet. It shouldn't be able to fly this fast or this quietly, yet it's currently crushing every competitor in the sky. Today, we're going inside the $7 million mystery of the most radical plane ever built. If you think you know how jet engines work, think again. The story doesn't start in a boardroom in Tokyo. It starts in 1986 in a small, sweltering town in Mississippi. Honda sent a young, brilliant engineer named Michimasa Fujino to a secret research facility. His instructions? Learn how to build a plane from scratch. At the time, Honda was at the top of the automotive world, but they were ghosts in aviation. Fujino-san didn't have a team of thousands. He had a small group and a blank piece of paper. For years, they worked in total anonymity. Why? Because if the aviation giants like Cessna or Gulfstream knew what Honda was cooking, they would have laughed them out of the industry. For a decade, they experimented with the MH-02, an all-composite experimental plane. It was ugly, it was clunky, but it taught Honda one vital lesson. If you want to beat the giants, you can't copy them. You have to break the geometry of flight. Look at the nose of a Boeing 737. It's rounded, like a bulb. Now, look at the HondaJet. It's sharp, elongated, and elegant. This isn't just Honda styling. Legend has it that Fujino was struggling with the nose design. He wanted natural laminar flow, a way to keep air stuck to the fuselage to reduce drag. He found his inspiration in a duty-free shop at an airport while looking at a pair of Salvatore Ferragamo stiletto heels. He literally brought those shoes to the design studio, scanned the profile, and that stiletto curve became the nose of a multi-million-dollar jet. This design allows for natural laminar flow, or NLF. In a standard jet, air becomes turbulent almost immediately after hitting the nose. On the HondaJet, air stays smooth for a much longer distance across the body. This results in a massive reduction in wave drag. When you're flying at 480 miles per hour, every millimeter of drag is a gallon of fuel wasted. Honda solved it with a shoe.
Now let's talk about the elephant in the room, or rather, the engine on the wing. This is the OTWEM, over-the-wing engine mount. If you look at any other light jet, a Learjet, a Phenom, a Citation, the engines are mounted on the rear of the fuselage. Why? Because putting an engine on top of a wing creates aerodynamic interference. The air hitting the engine clashes with the air lifting the wing, creating a chaotic mess that usually makes a plane stall or vibrate violently. Fujino spent 2 years inside a Boeing wind tunnel, testing the position of those engines down to the fraction of an inch. He discovered something shocking. There is one specific sweet spot where if you place the engine precisely, the air pressure from the engine actually helps the wing. By mounting them on the wings, Honda achieved 3 things that were previously thought impossible. The cabin is a library. Because the engines aren't bolted to the passenger cabin, there is almost zero structural vibration. You can whisper at 43,000 feet and be heard clearly. Infinite legroom. In a normal jet, the rear of the plane is filled with heavy engine support structures. By moving them to the wings, Honda freed up that space for a full private lavatory and a massive cargo hold. The efficiency miracle. The HondaJet is 20% more fuel efficient than any other plane in its class. In the world of private aviation, 20% is the difference between a profitable flight and a loss. If you've ever seen the cockpit of an old 747, it looks like a clock shop exploded. Buttons, dials, and switches everywhere. The HondaJet is the polar opposite. It's powered by the Garmin G3000 suite. It features 3 massive 14-inch landscape displays and 2 touchscreen controllers. It's designed for single pilot operation. This is crucial. Most private jets require 2 pilots, which doubles your salary costs. The HondaJet is so automated, so intuitive, that a single owner pilot can fly at the same ease you'd drive an NSX. But the real magic feature? Garmin Autoland. Imagine you're a passenger and the pilot has a medical emergency. In a normal plane, you're in serious trouble. In the HondaJet Elite 2, you can press a single red button. The plane takes over. It talks to air traffic control. It avoids mountains. It lowers the landing gear. It lands itself, applies the brakes, and shuts down the engines. It turns a nightmare into a non-event.
Most planes are made of aluminum sheets riveted together. If you run your hand over them, you feel the bumps. The HondaJet is different. The fuselage is made of a high-tech carbon fiber composite sandwich. Honda uses a unique honeycomb structure that makes the fuselage incredibly light but stronger than steel. Because it's molded, not riveted, the surface is perfectly smooth. This is the only way to maintain that natural laminar flow we talked about earlier. If there were rivets on the nose, the air would turn turbulent and the efficiency would vanish. This composite body also allows the cabin to be pressurized to a lower altitude. In a normal jet, you feel like you're at 8,000 feet, which causes fatigue and headaches. In a HondaJet, the cabin altitude is much lower, meaning you arrive at your destination feeling like you just walked out of your living room. Let's look at the numbers, because this is where Honda really hurts the competition. The HondaJet is faster, goes higher above most weather and traffic, and does it on significantly less fuel. When you're a flight department looking at the bottom line, the HondaJet isn't just a cool design, it's a financial no-brainer. But it wasn't always this way. In the early 2000s, people called it the Honda Putter. They thought it would be a toy. Today, it has been the most delivered aircraft in its class for 5 consecutive years. Honda didn't just join the market, they took it over. So where does Honda go from here? They've conquered the light jet category. Now they're aiming for the mid-size giants. The upcoming HondaJet Echelon, formerly the 2600 concept, is the big brother. It will be the world's first light jet capable of non-stop transcontinental flight across the United States. Imagine flying from Los Angeles to New York in a plane with OTWEM technology. It will offer the cabin space of a mid-size jet with the operating costs of a light jet. It's the next evolution of Fujino's dream. The HA420 is a testament to the power of the outside perspective. If Honda had hired traditional aircraft designers, they would have built a traditional aircraft. But because they allowed a car company to think like a physics lab, we got the most innovative wing design in a century. It's a plane born from a stiletto shoe, a secret Mississippi hangar, and 30 years of no. It's proof that in engineering, the impossible is usually just something no one has tried hard enough to solve. The HondaJet redefined the sky. But is it the coolest jet? Or does that title belong to the Cirrus Vision jet with its single engine and parachute? Let me know in the comments below. I read every single one. If you found this deep dive fascinating, do me a favor and hit that like button. It helps the algorithm show this to more aviation nerds like us. Don't forget to subscribe for our next breakdown of the world's most insane machinery.